In this segment, we will take up a problem from bending. Okay. Now, how the problem goes is like this. There is a steel strip, basically, whose length we have some length that we don't know yet, and then the width of the strip is 0.06 inch and the thickness is 0.005 inch. So basically I would say this is the cross section of the strip which we have. Now that strip we have taken and then we applied some moment m equal and opposite at both ends to bend this strip into a circle of radius 3 by 8 inches. Okay, now you have to assume now that though it's a very large deformation, assume that the limits of elasticity are still valid. There is no plastic deformation has happened, so that all the formulas which we have derived and discussed, they are applicable. This is an assumption which you have to have. Now under these assumptions, what we are supposed to figure out is the maximum stress that gets developed in the strip and the moment that we require to bend this strip into this circle. Okay, now for evaluating the maximum stress, we know that this is a function of the Young's modulus, the maximum fibers distance from the neutral axis, and the radius of curvature. Okay, and this being a rectangular cross section, the maximum fiber will be at a the neutral axis is exactly at the center, and the maximum fiber will be just half a distance, half of this distance from the neutral axis. So we have 29 into 10 raised to 6 psi is the Young's modulus of steel, then times 0.0025, half of this divide by 3 by 8 inches, so that is 0.375, and that will give us a value of 193.3 ksi. Okay, so that's the maximum stress that will be developed. So you should be able to think that on the inner side it will be compressive stress of this value, and on the outer side it will be a tensile stress of the same value, because the fibers are at the same distance from the neutral axis. Now to evaluate the maximum or the moment that we require, we will use this relationship, that is EI over rho, and now E is again the same thing, 29 into 10 raised to 6, but I is the thing which we should think about. What I we should use here? Okay, now the value of I can be calculated like this. So this is a 1/12 of BH cubed. Now the B value here is the width, that is 0.06 inches, and H is this depth from the neutral axis, and that is 0.0025. No, it will be the full height, right? So it is not the depth from the neutral axis, but it is the full depth of that means I'll show it here. So this is H, right? So, and this is B, right? Yeah, so 0.005 cubed. Now if you do that, you will get I, and if you substitute here, you will get a value of 0 0.0483 pound inches. Okay, so that's the value which you should get. So that was a cute problem on the concept of pure bending, and we will see another problem in the next segment on bending.